Okay, so you're here for pages 4 and 5 of the running test review. This time we're starting with solving linear equations, something that you definitely need to know how to do for algebra. So number 26, you're basically trying to solve it for x. So you're looking to simplify it first. So you would probably distribute the 5 to the x and to the negative 7. So we end up with 5x minus 35 equals 25. Then I'm going to add 35 because I want to get x by itself. So I'm adding 35 to both sides. That makes 5x equals 60. And then finally I want to divide by 5 on both sides so that the 5 cancels and I'm left with x equals 60 over 5, that's 12. So number 27 is longer, but actually it's the same principle. We want to combine like terms first if you can. So in this case I got 6x plus 28 on this side. And then over here I've got x's that can be added. Positive 4x, positive 5x, that's 9x minus 20. All right, now I want to get the x terms on one side and the numbers on the other. A lot of people like to do this in one step. I don't mind if you do, but really what you want to do is take 6x to this side. And I guess you can, if you want to do it in one step, add 20 to the other side. What this does is cancel this, cancel this. What I have is 48 equals 3x. And then I divide by 3, and I get x equals 16. 3 cancel. All right, number 28 is a little different because it's an inequality instead of just an equation. But really, we treat it very much like an equation. I would subtract the 9x from both sides. That'll give me 4 less than 3x minus 11. And then I would add 11. That's 15 less than 3x. And finally, I divide by 3. That gives me 5 is less than x. And you have to graph this on a number line. And sometimes this can be a little difficult, I guess, to remember. That when you have an x that ends up on the right side, you actually have to read it backwards. This says x is greater than 5. So I want to put a 5 here, and I want to put an open circle because there's no equals to symbol under the inequality. Then I want to shade to the right. So stuff you should know from these problems. For an inequality, you should know that if there's an equals to symbol under there, that you actually put a closed circle rather than an open one. And if you happen to divide in your final answer, divide or multiply by a negative, you'll have to flip the inequality symbol around. But in this case, we didn't do that, and you can usually avoid it if you take the smaller number to the other side, like we did up here. If we'd have tried to move the 12x over here, it would have left us with a negative 3x. We would have then had to divide by a negative. It makes it more complicated. So if you can just get rid of the right number in the beginning so that your answer stays positive here, would be better off. Okay, next up were some word problems that involve proportions. So these ones say a college student has 24% of its students majoring in physics. I see 24%, and I'm thinking 24 over 100. So anyway, let's keep going. If there are 420 students majoring in physics, how many attend the college? All right, so there's no real trick to this problem. We've got 24% over 100. And then the question over here is where does the missing value go? Does it go on the top or on the bottom? I told you right here, 420 are in physics alone. That means I want to know the total, which will be on the bottom. The 420 would correspond to the number on the top. So 24% is physics students, 420 is physics students. Those two numbers go on the top together. And then 100% is the total number of students goes on the bottom. I'm going to cross multiply here. I get 20 for x equals, got 42,000. That's what happens when you cross multiply. Probably a calculator work here. 42,000 divided by 24. I get 1,750. Again, your answer should make sense. If you got 100.8, it means you had these upside down. If you think about it, if there were 420 students majoring in physics alone, how could there only be 100 students in the high school? Or excuse me, in the college? In number 30, it talks about sometimes movies overlook minor details. In other words, sometimes they make a mistake when they're paying attention and they're not paying attention to some of the things they put in the movie. So this one says, in some movie, the Washington Monument, which is 555 feet tall, casts a 100-foot long shadow. So I'm already thinking that for the monument, it's 555 feet for the height and 100 feet for the shadow. Whereas the main character casts a 4-foot long shadow nearby. What's the flaw in the movie? Okay, what do I know about the main character? I know his shadow is 4 feet, but I don't know his height. So again, height of the monument over shadow of the monument. Height of the person over shadow of the person. Same kind of ratio. Again, I'm going to cross multiply. I got 100x equals, let's see, 2,220. That's the way to calculate it. 2,220. Divide by 100, I get 22.2. Okay, so the question is, though, what's the flaw in the movie? Well, according to this relationship, if they did it right, if the monument really did give a 100-foot long shadow, or only a 100-foot long shadow, then it would make this person end up being 22.2 feet tall, which doesn't make any sense. So what's probably wrong is that the person was supposed to give off a shadow that was probably, I guess, a little smaller than 4 feet. Okay, we're going to pass over those things into graphing. So now when you're graphing these problems, you basically have 3 forms of graphing that you need to know how to do. This kind, which is the easiest, where it gives you a point and it gives you a slope. So you need to be able to graph a straight line based off of a couple of different situations, but you're always looking for just a couple of points. So I'm going to put this on here. And now we can graph it. First thing I'm going to do with number 31 is plot the point they give me. Over to, up to, right there. That seems to make logical sense. And then I'm going to use the slope, which I know is rise over run. So if this is my slope, you're going to be leaving this a lot. Rise over run. The rise is either up or down. So because it's positive, it's going to be up. And then the run is always to the right. So I go up to, again, from the point I plotted, not from the origin, from the point I plotted, up to and right 3. Right there. And then I draw in a line. Number 32, we have a little bit of a different situation. Not too much different, but a little bit. So I make another X and Y axis here. Again, I'm kind of making these because I know a little bit about what the problem is going to look like when it's done. So I'm just trying to make it fit on here. All right, when I see an X and a Y together like this, it tells me that I should probably use the intercept method, which means I solve this as if, first off, the X term was there, but this was not. So in other words, I treat it like this. What I'm doing is getting an x-intercept. I do it again, but the next time I do it, I forget about the x term and I solve it with just the y. So what I really have is negative 3y equals 12. So y is negative 4. All right, the most common things I see with mistakes on this once people solve this is that they think it's one point. They graph the point 6, negative 4. No good. Also, people think this is a vertical line and this is a horizontal line. Also no good. Remember, you're trying to graph one equation, so you know it's going to be a diagonal line. This is an x-intercept, which means you go on the x-axis and put a point where x is 6. Right here. And this is a y-intercept, which means you go to the y-axis and put a point where y is negative 4. Here. And so once you've done that, now you have your 2 points and you can draw in a line. There you go. So the third kind of graphing that you would need to know is like number 33. This is slope-intercept form. This one's a lot like the first method. You need a point and an intercept, or excuse me, an intercept and a slope. Here's the intercept, here's the slope. This intercept tells you where there's a point on the y-axis. So I'm going to take that idea of positive 4 as the y-intercept and go to 4 on the y-axis right there. But I'm going to use the slope for rise over run. That means down 3 and right 4. So I'm going to go from here, down 3 places and right 4 places. Right here. So you can see it sounds an awful lot like the first one we did, where we plotted a point and then went back and used the slope to find the second point. It's the same thing here, except the point they give you happens to be a y-intercept right there. All right, the last two are really quite easy. It's just a matter of remembering a couple of special case scenarios. You notice I'm just using the horizontal line tool here because, actually, check that. I'm going to use the vertical line tool first because x equals 5. You have to remember that when there's a variable and only one variable in it, it's either going to be a horizontal or vertical line. And in this case, since it's an x, it sounds backwards of what you would think, but x is always a vertical line. So this says put a vertical line where x is 5. So here's 1, 2, 3, 4, 5. Here's where x is 5. Right here. So you should have a vertical line right there. This one says, okay, y by itself, but oh, well, no, only one variable. So if it's just one variable and it's a y, that means it's a horizontal line. This means you need to draw a horizontal line where y is negative 2. That would be right here. Like that. That's all there is to graphing. There's the 3 methods that you might have to learn, and then the special cases for horizontal and vertical lines. All right. Last step is to write some equations from various problems. So writing equations, I think, is only hard if you choose to make it hard. You are trying to do the same thing in every problem. That's write an equation using y equals mx plus b format. So in every problem, what you really want is an m and a b. So every problem should start out with what is m and what is b. So if you read through number 6, the says write an equation for the line that passes through 1, 2, and 5, 7. What I get out of that is that I have no idea what the slope is, and I have no idea what the intercept is. So that kind of stinks. It's going to be some tough work, but it can be done. I notice that I have 2 points, and so if I'm saying to myself, can I find the slope? Yes, I can, because I can use the slope formula. y2 minus y1 over x2 minus x1. That's the math way to write it. Most people just say subtract the y's over subtract the x's. So I got 7 minus 2 over 5 minus 1. It's going to be a pain because it's going to leave me a fraction, but sometimes it happens. So I know the m is now 5 over 4. I'll be able to put that in my equation now. Okay, the next step to this is to come up with what the intercept is, because you notice I can't write my equation until I know both. But here's what I do know. I know that it's going to fit this format, and I know I have a slope now. If I just knew what an x and a y were, I could find b. See, I have a point that is an x and a y. So I'm going to use the actual formula, but I'm going to stick in for y, I'm going to put a 2 there. The slope is 5 over 4. X is 1. I got b here. So really what I got is 2 equals 5 over 4 plus b. And so I would subtract the 5 over 4 from both sides. It's going to be a mess because of the fractions. These cancel. What I get finally is b equals, well, 2 minus 5 over 4. If you use the calculator, you could do it, but you should end up with 3 over 4. If you use the decimal, you get 0.75. So now I go back here and I know my intercept is 3 over 4. So I can write my final equation because I now have my intercept and my slope. So I'm going to write y equals, put my slope in, 5 over 4, write the x, and then put my intercept in, plus 3 over 4. This is the toughest of these writing equation problems, so you got it out of the way just now. All right, let's go to 37. Again, I'm saying to myself, I got to write an equation. I know the format, and I know I'm going to need an m and a b. So if I can figure out what those are, I should be good. So reading through the problem, write an equation for the line that has a slope negative. Wow, it tells me the slope. Okay, slope is negative 2, and passes through that point. All right, I don't have an intercept, but I just did right here the method of what happens when you have a slope and you're missing the intercept. So I'm going to do y equals mx plus b. But for the y, I'm going to put 4. And I'm going to put negative 2, x negative 2. And b is what is missing. So what I really have is 4 equals 4 plus b. And so if I subtract the 4 off, cancel that, I actually get b equals 0. Right? So I know that the slope is negative 2 and b is 0. So if I go to write my final equation, I should be writing y equals, and then my slope, which is negative 2, x. And then a lot of times people will write plus 0, just to show you that it's slope-intercept form. Really what this means is y equals negative 2x. So either one of these is an acceptable answer. All right, number 38 gives you a graph. I'm just going to draw a very quick picture of the graph they give you. All it is taking a graph and writing equations from a graph. So the important parts of this graph are that it looks like there's a point at right here at 3, And it looks like there's another one over here at 2, -1. The line is drawn in like this. Okay, so how do I come up with an equation for that? Keep in mind that I'm looking for a y equals mx plus b equation. I'm going to leave a space where m goes and where b goes because I don't know what they are. B I know is a y-intercept. Well, the y-intercept for this problem is right here. And it looks like that's at +3, so I'll put a +3 here. Now my question is what is the slope? Well, how did I find another point right here? How do I get from this point to that point? Because it's the same slope for any 2 points. So I go down 1, 2, 3, 4, down 4, and over 1, 2. That tells me I went down 4 and over 2. That's -2 when you simplify it. That goes here. All right, down to number 39 and 40. Last one. Okay, 39 says write an equation for a line that is perpendicular to that stuff and passes through 6, -4. Again, I'm asking myself, what is my slope? What is my intercept? Okay, my slope. Doesn't say anything about a slope. Doesn't say anything about an intercept. Okay, you're writing a new line. So the most common mistake is people try to use this line for stuff. The key term here is perpendicular. And so it's perpendicular to this slope. In other words, it's opposite sign and reciprocal to that slope. So your slope is to flip it over and change the sign. The slope you want is 4/3. Okay, the important part here is once you get the slope from this equation, you don't need any of it anymore. All you really need is your slope and this point. We're back to just like the other 2 problems were. Let's do our equation. So let's put in the values that I now know. -4 for y. Slope is 4/3. X is 6. And the missing b bar. Alright, if I'm solving for b, 4/3 times 6. Well, 4 times 6 is 24, and I divide by 3, I get 8. You could also do it on the calculator if you have to. So now I'm going to subtract 8 away. I get -12 equals b. That goes here. My final answer is the actual equation that I would get. So y equals m, x, and b is -12 this time, so I write -12. There's your final answer. All right, last one, number 40. What is m? What is b? Again, write an equation for a line that's parallel to whatever and passes through 1/4. Nothing about slope, nothing about intercept. But here's the key word, parallel. Parallel to this slope. Parallel means equal slope. So the line that you want is going to also have the same slope as that one, so our slope is 5. Now I'm going to use this point that I'm given. Y is 4, m is 5, x is 1, and then the missing b. In other words, I got 4 equals 5 plus b. If I subtract 5 off, I got b equals -1. So I write my final answer with my slope 5, x, and with my intercept -1. Okay, so that should take care of everything on the review. Your test is actually now on Wednesday. Which is October 26th. All right, good luck.